So if we're asked to evaluate this integral, let's do what we usually do. Let's think about what the antiderivative of sine of x with respect to x is. And so that's where you want to go back to your first study of derivatives, of trig functions. The derivative of cosine is negative sine of x, right? So the antiderivative of sine of x is going to be negative cosine x, because we're with an antiderivative, think about something so that if you take its derivative, it turns back into what you started with. If you take this derivative of cosine is negative sine, so negative cosine makes sine. Okay, but that's the antiderivative part. We're supposed to evaluate it between 0 and infinity. Now, we can't really plug in infinity because infinity is not a number. Okay, so this isn't technically correct. I mean, it's written in textbooks too, I guess. So I've heard from some professors that you should never do this. You should write it like this: the limit as x goes to infinity for x. Okay, because we can never reach infinity, so we can never plug it in, but we can evaluate the limit as x goes to infinity. So that's the upper part of our limit of integration. And then we're going to subtract it by the lower part. Nothing wrong with this lower part. We can evaluate that, right? Cosine of 0 degrees. Cosine is the x-coordinate on the unit circle, so that's 1. So -1 minus -1, that means we're doing +1. But this right here, can you evaluate that limit? If you remember back at the beginning of the study of calculus, this is an oscillating discontinuity. Right? It never converges to a limit as x goes to infinity. If you graph cosine of x, and this is negative cosine of x, so it starts at -1, then up to +1, then -1, +1. As x goes to infinity, we can keep drawing this until the cows come home, but it's never going to reach one value, right? It doesn't converge to some value, so this is not defined. So that means we say that this entire integral quantity diverges. Okay, this diverges because we can't evaluate that limit as x goes to infinity.